Hello my dear student, I hope all of you are fine at home during this lockdown period. I already uploaded a video lecture on matrices. We discuss in some introduction in basic concept of matrices there. I will cover in this session some basic operation of matrices such as addition of matrices, subtraction of matrices, multiplication of matrices. Okay, you go through this session. Okay, now let's start the video. First we will discuss operation of matrices. In operation we will discuss first addition of matrix. If A equal to Aij and B equal to Bij are two matrices of same order, say M by L, that is order of the both the matrix is same, that is we said it as M by L. Then the sum of two matrices A and B is defined as a matrix C, which is equal to small c ij of order M by L, where element of C matrix, that is small c ij, will be equal to Aij plus Bij for all possible values of I and j. For all possible values of I and j. The concept will be clear if we explain it through an example. Suppose a matrix A equal to 2, 3, 4, 1. It is of 2 by 2 matrix. That means order of this matrix is 2 by 2. We will consider another matrix B, -1, 0, 3, 2. That is also of 2 by 2 matrix. That means both are the same order. Both are of the same order. So now a matrix C, suppose C equal to A plus B. Addition of these two matrix will be like that: 2, 3, 4, 1 plus -1, 0, 3, 2. We will add the corresponding elements like this: 2 plus -1, that it become 1. With this one we will add this one, 3 plus 0, that is 3, and with this corresponding element we will add the corresponding element. It is the first element, we will add the first element of this matrix. First element of A matrix and first element of B matrix we will add. Then 4 plus 3, that is 7. Then 1 plus 2, it is 3. That is the resultant matrix, our required matrix. Now next topic of discussion will be multiplication of a matrix by scalar. A matrix A is represented as Aij M by L is a matrix and K is a scalar. Then K into A is another matrix, is another matrix which is obtained by multiplying each element of A by a scalar quantity by a scalar K. That is K, A will be equal to K of Aij m by L. It will be clear. We'll clear this one by taking an example. For example, we are taking a matrix A as 1 3 2 1. Okay, we are taking an example A equal to 1 3 2 1, a matrix of order 2 by 2, and we will take a scalar, suppose K equal to 4. And what is the value of Ka? We are putting the value of K as 4 1 3 2 1. By the rule of multiplication of matrix by a scalar, we simply multiply each element by this K, by this 4. 4 into 1, that is 4. 4 into 3, that is 12. 4 into 2, that is 8. And 4 into 1, that is 4. So simply we can multiply a matrix by any scalar quantity. Here I am taking an example by K equal to 4. Okay, now here another operation of matrix, negative of matrix. A matrix can be written as in terms of negative 1. To find negative of a matrix, negative of a matrix, we have to multiply the matrix by -1. Here -1 is considered as scalar quantity. Suppose that is A, negative of matrix minus A will be -1 into A. Example, we'll explain it with the help of example. Suppose A equal to 0 1 3 -2. You have to find the negative of this matrix. So minus A will be equal to -1 of 0 3 1 -2. Right? According to the scalar multiplication law, you have to multiply this number with all of this element. Okay, 0 into -1 into 0, that is 0. -1 into 1, that is -1. -1 into 3, that is -3. -1 into -2, it will become +2. This is the negative of matrix A. -1 into 0, that is 0. -1 into 1, -1. -1 into 3, -3. -1 into 2, that is 2. This minus plus. So it is the required negative of matrix. Negative of this matrix A. Okay, now we will discuss difference of matrix. If A equal to Aij m by L, comma B equal to Bij m by L are two matrices of same order. Here order is m by n and m by n. Both the order are same. Then the difference, a minus b is defined as a matrix capital D, where Dij, it is of the order m by n, where value of this D matrix, that is element of Dij, will be Aij minus Bij. We'll get the elements of matrix D by subtracting A and B. For all values of I and J. Okay, we'll explain it with the help of example. Suppose A equal to 2 0 minus 1 minus 3. It is of order 2 by 2. 1 minus 1 0 3. It is of order 2 by 2. Both are the same order. Order of the both the matrices are same. So we will find A minus B. 2 0 minus 1 minus 3 minus 1 minus 1 0 3. It is similar like the addition of the matrices. Now we will subtract corresponding element. First element of A minus first element of B matrix. So 2 minus 1, that become 1. 0 minus of minus, it become plus. 0 plus 1, that is 1. Minus 1 minus 0, it become minus 1. Minus 3 become minus 6. So as difference of two matrix will of the same order. Okay. Now we'll discuss properties of matrix addition. That means matrix addition follows some rules that may be commutative. First one is commutative law. If A equal to Aij m by n, if A equal to Aij of m by n order and B also equal to Bij of m by n order. According to commutative law, it's follow the principle A plus B equal to B plus A. You can easily explain with the help of any examples. Okay, that is easier for one. You can easily explain. Okay. Now come to associative law. For any three matrices, suppose A equal to Aij, comma B equal to Bij, and C equal to Cij. It follows the associative law. They are of same order. Say m by n. They will follow the law of associativity. Law of associativity was like that way. A plus B plus C will be equal to A plus, that is B plus C. This we will sum up these two first, then we will add this one with the resultant and we will get this sum. That is the associative law. Third one will be existence of additive identity. It is of the property of addition of matrices. Let A equal to Aij M by L be any matrix and O be M by L zero matrix. O is zero matrix. Then A plus O equal to O plus A, which is equal to A. Simply adding the elements 0, as it's of same order, M by L. It was also M by L. So after the adding, you will get the same A. Then O is called as additive identity. Additive identity. Okay, now we'll discuss another application of this, existence of additive inverse. Now we'll discuss the existence of additive inverse. Let a matrix A equal to Aij of M by L order be any matrix. Then we have another matrix minus A, which is equal to minus of Aij of same order M by L, such that A of plus minus A, that is equal to minus A of plus A, is equal to zero matrix. Then minus A is called additive inverse of A. Okay. Now we will discuss properties of scalar multiplication of matrix. We already discussed how a scalar is multiplied with a matrix. Now we will discuss some properties of scalar multiplication of matrix. Suppose a constant k is multiplied with two matrix A plus B. It is of the form A plus B. Then it become constant is multiplied with both the matrices. We can explain with the help of an example. Suppose k equal to 2. It is the value of that scalar. Scalar value is 2. And A is a matrix of 2, 0, 1, 1, 2 by 2 matrix. And B is also a 2 by 2 matrix, 1, 3, minus 1, 0. Then 2 of A plus B, that is 2 of 2, 0, 1, 1 plus 1, 3, minus 1, 0. After the adding, 2 plus 1, 3, 0 plus 3, 3, 1 minus 1, 0, 1, 0, 1. So it become multiply 6, 6, 0, 2. This is the result. You can similarly check by putting the value of k equal to 2 and A and B by this matrix. Separately you can check it out. Okay. Now here is another property. Suppose two scalar k, l, l, 2 scalar and a matrix multiply, and simply the scalar is multiplied with that matrix. It will be splitted like the associative one. So I am going to prove this one. Okay, you can easily prove this one by taking early examples. Suppose K is given as 2, so Ka plus Kv, 2 of, what is the value of A? 2011 plus 2 of 13 minus 10, multiplying with 2 4022 plus 26 minus 2 and 0. Add this to 4 plus 2, that is 6, 0 plus 6, 6, 2 minus 2, it is 0, 2 plus 0, 2. These two are same. So this and this are equal. That means property, this one is proved. So you can prove also this property by taking an example. I think we get that one. You can note it down by taking the screenshot, pause the video and take the screenshot. Okay. Now we will discuss a questions. It is the question of NCERT book. I am giving you question from the NCERT book itself. The question is, if a matrix is given, it is of the order, what is the order of this matrix? 3 rows, 2 columns, that is 3 by 2. A 3 by 2 matrix is given, both the matrices are 3 by 2. Then find the matrix X. They asked us to find the matrix X such that there is a condition 2A plus 3X equal to 5B. First we will go to the condition 2A plus 3X, that is equal to 5B. What we have to find? We have to find the X, matrix X. So we will take it in left hand side and 2A will be in right hand side. Yes. So X will be equal to 1/3 of this 5B minus 2A. So now put the value of A and B. 5 of B. First it was V. What is the value of V? 2, 4 minus 5 minus 2, 2, 1 minus 2 of A. 8, 4, 3, 0 minus 2, 6. 1 by 3. Now what is the result will be this? A scalars multiply with the matrices. 5 to the, it become 10 minus 10, 20, 10 minus 25, 5 minus 2 will be multiplied with each and every element of this matrix. 2 8 are 16, it is 0, 2 0 0, 2 4 ja 8, 2 into minus 2, that become minus 4, 3 2 ja 6, 6 2 ja 12. Now what we have to do is subtract difference of these two matrices. We already discussed how we can find the difference. Subtracting first one, second one from the first one. 10 minus 16, it become minus 6. Then minus 10 minus 0, it become minus 10. 20 minus 8, 20 minus 8, what it become? 12. 10 minus of minus 4, 10 plus 4, it is 14. Minus 25 minus 6, that is minus 31. 5 minus 12, minus 7. And here as a 1/3. That means we have to multiply 1/3 with each and every elements of this matrix. So 6 into 1/3, that will be minus 2, that will be minus 10 by 3. 12 into 1/3, that will be 4. 14, that will be 14 by 3 minus 31 by 3, minus 7 by 3. That is the result. What they asked us to find the value of x. It is the value of x. Now we will do few more questions from addition of matrices. This question is from your NCERT textbook. If a equal to this is given, they asked us to find a plus b and 3a minus c. We'll solve this one. First one, simply addition of these two matrices a plus b. We simply write the matrix 2 4 3 2 plus what is the v 1 3 minus 2 5. By adding the corresponding element, that means first element of the matrix A with first element of matrix B. 2 plus 1, that is 3. 4 plus 3, 7. 3 plus minus 2, that is 1. 2 plus 5, 7. It is the result. As simple as that. We will know second part. Second question, 3a minus c. 3a 2 4 3 2 minus c is minus 2 5 3 4. Now 3 is a scalar here, so we will multiply with each and every element of a by 3. 3 2 ja 6, 3 4 ja 12, 3 3 ja 9 and 3 2 ja 6 minus 2 5 3 4. What is the difference of these two matrices? We already discussed how we can find the difference of two matrices. 6 minus plus, that is 8. 12 minus 5, 7. 9 minus 3, 6. 6 minus 4, 2. That is the result. Okay, now we will do another questions computing the value of this of addition of the matrices. Easier one, not the tough one. First one, how we can solve ab minus ba plus ab and ba. We have to add the corresponding element. This is the first element, this is the first element. So a plus a plus a and b plus b is minus b plus b, a plus a. What it become? A plus a, it is 2a, b plus b 2b, minus b plus b 0 and 2a. That is the resultant. Now we will do this second one. Second one, what was the question? Second one, minus 1 8 2 4 5 8 minus 6 16 5 plus 12 8 3 7 0 2 6 5 4. We have to add these two matrices. Order of both the matrices are same, so there is no issue. We can simply add corresponding element. Minus 1 plus 12, it become plus 11. 4 plus 7, 11. Minus 6 plus 6, it becomes 0. 8 plus 8, 16. 5 plus 0, 5. 16 plus 5, 21. 2 plus 3, that is 5. 8 plus 2, 10. 5 plus 4, 9. That is the result. It is as simple as that. Okay. Now we will do another question. It is of the NCERT questions. How can we solve this one? They asked us to simply add these two. So question is cos square x sin square x cos square x plus sin square x cos square x cos squared x, sin squared x. Both are of the same order, 2 by 2. We'll add the corresponding element, the first element plus first element of the second matrices. So cos square plus sin square x, cos square x plus sin square x, second sin squared x plus cos squared x, here sin squared x plus cos squared x, here in cos squared x plus sin squared x. You already get this in trigonometry. What is the value of cos squared x plus sin squared x? 1 1 1 1. That is the result. Okay, thank you for your concentration.